Okay, let's unpack this. Welcome to the deep dive. This is where we take, source material, articles, notes, whatever you've got, and we really drill down to get the key insights.
Exactly. We try to be your shortcut to getting up to speed on, well, sometimes pretty dense topics.
And today, yeah, we're diving into some material around the Juniper Network's JN0-460 exam.
That's right, specifically focusing on the JNCIS-MistAI Wired certification track.
Right, the source material you gave us has the basic exam details, but the really interesting part looks like these practice questions, with the answers and the explanations.
Yeah, that's where the real substance is, I think. It gives us a window into the core concepts.
So our mission here is basically to unpack these questions and explanations. We want to get a clearer picture of the key ideas in this JNCIS-MistAI-Wired stuff.
And hopefully make some of these potentially complex ideas a bit more accessible. Highlight the big takeaways for you listening.
Yeah, I'm definitely curious. It's not just about the exam, is it? It's about understanding the tech.
Absolutely. Things like, EVPN, Mist AI features, virtual chassis. These are really fundamental now for modern wired networks. Understanding why they matter is key.
Okay, so let's quickly cover the basics from the source. The exam itself, JN0-460, JNCIS-Mist AI Wired.
90 minutes, 65 multiple choice questions.
Standard stuff.
Right.
English language, $300 USD fee.
Yeah.
Got it.
That's the wrapper. But like you said, the content, the questions, that's where we see what's actually considered important.
Agreed. Let's jump into that first practice question then. It asks about the main function of an EVPN route type 2, specifically in a campus EVPN VXLAN setup.
Okay, EVPN route type 2. So EVN, Ethernet VPN, that's it, control plane tech, right? For overlay networks like VXLAN, it helps figure out where everything is.
Right. And type 2, the source calls it the MAC-IP advertisement route. So what's the key thing it does?
Well, the big takeaway here is that it carries both the MEP address and the IP address information for end devices, all in one go.
Both. Okay, why is that combination important? Why bundle them?
It makes learning host locations much more efficient across the VXLAN fabric. Switches, or VTPs, learn the MA and the associated IP address together.
So they know exactly where that specific device is, both layer 2 and layer 3, from one message.
Precisely. It streamlines things, helps optimize forwarding within the overlay network, reduces flooding, like for ARP, it's just cleaner. You get the whole picture at once.
Got it. One efficient update instead of potentially several steps. Makes sense.
Yeah, it's a core piece for making EVPN VXLAN work well.
Okay, shifting gears. The next question in the source material looks at Mist wired assurance, specifically the switch onboarding part. It asks for a key advantage.
Right, and the advantage highlighted is the dynamic device provisioning using cloud-based templates.
Dynamic provisioning, cloud templates. That sounds quite different from the old way. Logging into each box, typing config line by line.
Oh, absolutely different. The benefit here is really about simplifying and speeding up deployment. Massively.
How does it work in practice then?
Basically, you plug the switch in, it connects to the Mist cloud, identifies itself, and bam! It automatically pulls down the configuration that you've already set up in a template.
So you build a config profile once in the cloud, assign it.
And the switches just grab it when they come online. Zero touch, essentially. It gets rid of all that manual device-by-device setup.
Wow, the efficiency gain there must be huge, especially for, large campus rollouts.
It really is. It's a major shift towards automation. Less manual work, fewer errors, much faster.
Okay, let's talk about simplifying the hardware side. Next question is about virtual chassis in a Juniper campus network. Primary purpose.
The source says the primary purpose is to simplify management.
How does it do that?
By letting you combine multiple physical switches, could be, say, 4 or 8 switches, and making them act like one single logical device.
Okay. So instead of managing 4 boxes separately, you log in once, configure once, monitor once. Like it's just one big switch.
That's the core idea, yes.
Right.
From a management perspective, configuration, monitoring, software upgrades, you treat the whole stack, the virtual chassis, as a single entity.
That definitely sounds simpler. Less administrative overhead.
That's the main driver. Reduces the number of management points drastically. Of course, you still need to cable it correctly and understand failover, but operationally, day-to-day, it's simpler.
Right, like having one remote for your whole AV system instead of 3 or 4.
Yeah, that's a pretty good analogy. Consolidates control.
Okay, moving on. Question 4 gets into AI. It mentions Marvis, the virtual network assistant, in the Mist AI context. What's the benefit here?
The source highlights something pretty cool. Marvis provides human-like interaction for diagnosing network issues.
Human-like interaction. How does an AI pull that off for network troubleshooting?
Well, Marvis is AI-powered, integrated into the Mist platform. The human-like part comes from its natural language interface, meaning you can literally ask it questions in plain English, like, why are users in Building C having bad Wi-Fi experiences, instead of needing specific CLI commands or digging through logs manually?
Seriously, you can just type that in.
Yeah, or even use voice in some interfaces. And Marvis uses all the telemetry data it's collecting to analyze the situation and give you insights, potential root causes, even suggested actions.
Okay, that's pretty advanced, combining AI analysis with a conversational way to query the network.
Exactly. It helps IT teams diagnose problems much faster, and it's often proactive too, suggesting things based on anomalies it detects, not just answering your questions.
Very interesting. Feels like a step change from traditional monitoring.
It definitely is. A move towards more intuitive AI-assisted operations.
All right, question 5. This one's a select 2 type. It's about deploying layer 3 gateways at the distribution layer. What are the outcomes?
The two correct outcomes given in the source are, first, it enables local interval LAN routing,
Okay,
and second, it enhances scalability and fault isolation.
let's break those down. Local inter-VLAN routing. How does putting L3 at distribution help with that?
Well, think about it. The distribution layer is where different VLANs from the access layer often converge, right?
Mm-hmm.
If you put the layer 3 routing intelligence there, on that distribution switch, any traffic that needs to go from one VLAN to another within that block gets routed right there, locally.
So it doesn't have to travel all the way up to the core layer and back down just to switch VLANs.
Exactly. Keeps traffic local, reduces load on the core.
Okay, and how does that connect to the second point, enhancing scalability and fault isolation?
By pushing that layer 3 boundary closer to the users, you effectively shrink the size of the layer 2 broadcast domains. Each distribution block becomes its own routing domain, largely independent.
Right. Smaller broadcast domains are generally good, less chatter.
Less broadcast chatter, yes, which improves overall efficiency and helps the network scale better. And for fault isolation, if something goes wrong at layer 2, like a broadcast storm or a loop,
It stays contained within that one distribution block.
mostly yes. The layer 3 boundary acts as a barrier, preventing the problem from flooding the entire network. It makes the design more modular, more resilient.
So it's a strategic design choice. Better performance, more robustness by keeping things local.
That's a great summary. It's a very common and effective architecture.
Okay, last question from the source. This one's about Mist AI's telemetry and how it supports proactive operations.
Right. The key mechanism here, according to the source, is that Mist AI automatically analyzes performance metrics and triggers alerts based on that analysis.
So it's not just collecting data, like SNMP polling.
No, it's way beyond that. It is continuously collecting really detailed telemetry performance configuration, events, client states from the switches. But the crucial step is the AI analysis.
What does the AI do with all that data?
It looks for patterns, trends, anomalies, deviations from normal baseline behavior. It uses machine learning to identify potential issues, sometimes things a human might miss, and can even predict problems before they actually impact service.
Before users notice.
That's the goal. It triggers alerts based on these AI-driven insights. For example, maybe it sees error rates subtly creeping up on a port, or client connection times degrading slightly. It flags it proactively.
So it's spotting the early warnings, not just waiting for a hard failure or a user complaint call.
Exactly. It shifts the whole paradigm from being reactive, fixing things after they break, to being proactive. You get alerted to potential trouble, investigate, and hopefully fix it before it causes a real outage.
That proactive element feels like the game changer, moving away from constant firefighting.
It really is. That's a core promise of AIOps, AI for IT operations applied to the network.
So as we wrap up, here's something to think about, based only on what we've discussed from these sources. Consider how all this automation and AI, we've touched on the cloud templates, Marvis talking back to you, the proactive alerts from telemetry. How does that fundamentally change the job of a network administrator compared to the old ways?
That's a big question.
Yeah.
What does this shift towards these more intelligent, automated networks really mean for the future, for the skills needed in IT roles going forward?
Definitely something to mull over. Thanks for digging into this with us today.
My pleasure. Good stuff to think about.